today is a good lesson, and it's a short lesson. And it's a short assignment, and you get a work day on Friday, you get a work day on Monday. Test it on Tuesday. Thought I handed that all already, didn't I? Okay. If you remember, when we first started talking in this class, we started talking about how to find an equation for a line tangent to a function at a given point. That was the big question we asked. And when we started to ask that question, it brought us to this idea of looking at limits. We're like, what is the number trending towards? And that's going to be the slope. Well, that brought us to the study of limits, and the study of limits brought us to the study of continuity, and now we can talk about the slope of a tangent line. So if we have a point, we'll call it A, and a line tangent at that spot, we want to be able to find the slope of that line. The problem is that we only have one point. So what do? We get a second point. We'll call that point X. You can teach class tomorrow. So what is the Y value? F of X. And that helps me create a secondary line. It's not the tangent line, but the secant line. Okay? So if we want to define the slope of the tangent line, we do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. What is y sub 2? What is y sub 1? But that gives me the slope of the secant line. If I wanted the slope of a tangent line, what do I have to do to x? Move it. Now, that used to sound challenging to do, and now it's no big deal. We just understand that you just put a limit on it. You take x and you move it towards a. That's now the slope of the line tangent. Here's what's cool about it. If you plug in a for x, what do you get? 0 over 0. And so that big question, what is 0 over 0? 0 over 0 is an indeterminate value. We don't know. And today we're going to come up with lots of situations where we use 0 over 0, and you kind of wonder what is the output of it. But let's look at this type of equation. We got this equation for line tangent to the function. We're going to use this definition 1. We're going to teach you definition 2 after the test. We're going to use a different one later on. But I have my point. My point is 1, negative 2. And what I need to find is my slope. In order to find my slope, I do the limit as x goes to a of f of x minus f of a all over x minus a. Now, on your worksheet, I don't give you the y value, okay? A lot of people struggled with this. I didn't think that would come up, but we'll pretend like you don't see the negative 2 there, okay? I have the limit as x is approaching, what's a? What is the x value that we want to approach? 1. What is f of x? X squared minus 3 minus f of a. That's what you get if you plug a back into the function. If you plug a in, you get negative 2. So it'll be a plus 2 divided by x minus 1. So that's the limit we're trying to solve. The limit as x goes to 1 of x squared minus 1 over x minus 1. Again, if you plug in 1, what do you get? 0 over 0. Okay? This is discontinuous at what value? 1. Remember we talked about discontinuity? Remember how we talked about filling the discontinuity? Well, we're going to do that right now. We're going to remove the discontinuity and fill that. So we get the limit as x goes to 1 of x plus 1 times x minus 1 over x minus 1. Discontinuity is removed. If we were to fill the discontinuity, what would the value be? 2. That happens to be the slope. So every time we talk about a line tangent at a single given point, we're always talking about a removable discontinuity that we then fill. Whatever you fill it with, that is the slope every single time. The calculus is beautiful. Yes. Yeah. So it's f of x, which is that, minus f of a, minus negative 2. Yep. It's your y value. F of a is a y value. Okay. Let's try next one. Okay. Oh, well, we haven't written the equation for line tangent yet. So we got y minus, what's our y value? So plus 2 equals m times x minus 1. So y equals 2x minus 4. If we go to y equals, we type in x squared minus 3, and we go 2x minus 4, zoom standard, and what do you know? Is the line tangent? Perfect. Pretty hard to do. We made it easy. Slope, point on the line. Point on the line is 223. Suppose I didn't know that the y value is 23. How would I figure that out? Plug in what? Plug in 2, and you're able to generate the value of 23. So I have the limit as x goes to what? 2 of 2x cubed minus 1 minus 2 all over, not minus 2, minus 23, all over x minus 2. The y value goes on top. You guys, this is just y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Thank you. Best friend ever. Here we go. The limit as x goes to 2 of 3x cubed minus 24. Right now you're wondering, like, is that really going to cancel? Is it going to be a removable discontinuity? Can we factor x cubed minus 8? Difference of cubes, right? If it didn't factor, what would you do? So if it didn't factor, that's all you have to do. Just divide synthetically and it'll work out. Okay, so we'll factor it because that's what you want to do. Limit is x goes to 2 of 3 times x minus 2. Square the front, square the back. Multiply 2 in the middle and opposite sign. Very good, Spencer. Spencer knows what's going on. He did his homework. Way to go. Notice the discontinuity is removed. We fill it. Plug in the 2. Square root is 4, plus 4 is 8. 12 times 3 is 36. Calvin, question. This? No. X plus 4 times x plus 4? So that'll be x plus 4 times x plus 4 is x squared plus 8x plus 16. So x plus 2 times x plus 2 is x squared plus 4x plus 4. But we got a 2x. The trinomial that comes up when you factor the sum or difference of cubes when it's third degree, it never factors. It's always an imaginary solution. So, okay. All right, so we have y minus what? 23 equals 36 times x minus 2. Y equals 36x. We've got a negative 72 plus a 23. Minus 49. Beautiful. Flip it over. We're going to skip A and B, and we're not going to use definition 2. I'll do that later. We will end with definition 1 still. We just have these two examples, and you'll have your worksheet. Let's find the slope. Limit as x goes to what? 6 of square root of x minus 2 minus 2 all over. How do I, it's kind of ridiculous to think, but the discontinuity does go away here. It does. Yep, when you don't know how to do it, do Spanish. Conjugate. Okay, so for YouTube Nation, I brought up the conjugate, which brought up Spanish, and leave it to Brody Nielsen. Starts then whining about how we don't have nachos anymore for lunch. So, any other references we need to get out of the way? Chicken patties are great. Okay, great. All right. Well, good. Oh, man. All right. Life is tough. It's tough. You guys should sign a petition. All right, what do we get? Now, it's very important that you write the denominator as these pieces separated because, again, you want to look for them to cancel. So we get the limit as x goes to 6 of x minus 6. And I say this because some of you started multiplying this through to get like a 4-term polynomial on your last test. You want the x minus 6 to go away. So leave it here so you can see it cancel. Don't multiply it through. What am I left with on top? Can you plug in the 6? What do you get? 1/4. I need to write the equation for the line. Y minus 2 is equal to 1/4 times x minus 6. So I have a 1/4 x. 1/4 times negative 6 is 3/2 plus 2. Negative 3/2 plus 2 is going to be positive 1/2. Equation for the line tangent. Okay. Last one. Limit as x goes to 3 of There we go. And if you did plug in 3, you would see that you get 0 over 0. I'm going to trust that this discontinuity is going to be removed. I should see an x minus 3 pop up here. If I don't, I did something wrong. So what do? Common denominators. Go get some brain food. Come back smarter. We'll finish this off. All right, I've written it as a complex fraction. What am I going to want to make sure it cancels out? Not the x minus 1s. I want the x minus 3s because the 3 is causing the discontinuity. Whatever's causing the discontinuity is what you want to remove. It's the whole idea. So if you don't come up with something, there's a problem. So I get a 3 minus x over 2 times x minus 1, x minus 3 over 1. Whoop, x minus 3 over 1. Now what? Yeah, very good, Andrew. What? You good, Carter? Okay. Take out my negative 1. I'm going to put it over there. Is that all right? With that negative 1. So, thank you, Carter. I got negative 1 over 2 times x minus 1. Captain Obvious. Plug in the 3, we get right? Negative 1/4. So we got y minus a half equals negative 1/4 times x minus 3. So y is negative 1/4 x. Negative 1/4 times negative 3 is 3/4. Add the half. 5/4. I'm wondering, is that right? I go to my calculator, I type in 1 divided by x minus 1, and then I type in negative 0.25 times x plus 5/4, or 1.25, whatever you want. Zoom standard. I hope I see a tangent line. Stupid. I go negative 2 to 4, or I'm sorry, positive 2 to 4 to zoom in. So I go, so right around 3. And then what's the y value at? 1/2, right? So I'll go down to negative 1, and I'll go up to positive 2. And that should create a nice small window to see exactly what this graph looks like. Yeah, right. It does, doesn't it? So if you wanted to try to stretch a graph a little bit, you could. And if you went to, like, say, negative 5 into positive 8, let's see if that stretches the graph. Whoop. Wrong direction, huh? Let's try again. Sorry about that. We said y minimum, we said was half. So we'll just go we'll go 0.2, and then our max will go up to, say, 1, and see if we see a better picture here. Yeah, well, it's how limited our technology is, right, in terms of the pixels and everything. But who, Who asked him to even talk?